So a kite is made up of 4 right triangles. A helpful theorem that you might want to have is the Pythagorean theorem. So that's a squared plus b squared equals c squared, or we talked about leg squared plus leg squared equals hypotenuse squared. It's also made up of 2 isosceles triangles. So we've got an isosceles triangle on the top. Okay, 2 sides are congruent. And then we have another isosceles triangle on the bottom. So we have 2 other sides that are congruent. And the area of a kite is given by the formula diagonal 1 times diagonal 2. So diagonals here are, no, don't do that. There we go. Our diagonals here are the dotted lines that you see in the middle. So the dotted lines there are our diagonals, okay? One thing that we know is that the opposite angles in a kite are congruent, but only one pair of opposite angles. So these guys right here, WX and XY are congruent. And we talked about WZ and ZY are congruent. Those are called disjointed sides. So they're congruent to each other, to the one next to it, but not to the one on the other side. They're disjointed. And the angle in between those congruent pieces is what is congruent. So this angle here is congruent to this JK. Other way, the disjointed angles here are congruent. Okay? And so that's kind of something that we'll need to know. We also know that this is a right angle, and that's because of that perpendicular bisector theorem. So the first question here says, find the measure of QZY. So first I got to figure out where is QZY. QZY is right here, QZY. Well, I know this is a right triangle, okay? So I know this is 90 up here. So that means I've got let's turn that into a different color so we can see it. So we've got 90 plus 56 plus angle QZY should equal 180 degrees. And we should be able to solve that. Now, I am going to use a calculator to do that. Because I don't trust myself. So that's 146 plus QZY is equal to 180. And then we subtract 180 minus 146. And I get 34. Okay, so that would tell me that this angle right here is 34. Now it also asks for the length of WY. So here's the deal. Because I know that this is a perpendicular bisector, I know XZ is a perpendicular bisector of WY. That means that QY and QW are congruent. So if this is 12 millimeters, then this is 12 millimeters as well. So when I'm asked for WY, I would just add those together, 12 plus 12, and the length would be 24 millimeters. Is kind of more of the same, but now we're going to start applying our Pythagorean theorem. So the first question is, what is BD? Okay, well, we know BE is 6, and since we know this is a perpendicular bisector, it's the same kind of triangle that I had in the last picture. It's just turned, I'm sorry, not triangle, it's turned on its side, so that's still a right angle, which means that this is still congruent to this. So hit me up in the chat. What do you think BD might be? So I'm going to add that 6 there and this 6, and BD is going to be 12. So it's the total length there. AB is this guy over here. And so I'm going to have to use Pythagorean theorem to solve for that guy. So I've got to look at this is a leg right here, and this is a leg, and I'm trying to figure out the hypotenuse. So I'm going to do 6 squared plus 13 squared, and that's going to equal AB squared. So I'm going to do that in my calculator. I know what 6 squared and 13 squared are, but to add those together, if I can do it in my calculator, this is why you should have a handheld calculator and not your phone. So I got 205 is equal to AB squared. Now, we're looking at a length. In your life, has anybody ever said, the length of that line is radical 205? No, people don't talk in radicals. So when we take the square root of both sides here, we are going to take the square root of 205. We are not going to use radicals to approximate that. Or to make it exact. We are going to approximate that. So AB is going to be approximately equal to 14.3. Questions on that one? AC is our next piece. So we got to find AC, and AC is right here. I bet you guys know how long AC is. That should be an easy one, right? Okay, so AC, we just add those up together. So AC is 13 plus 8, or 21. Now, the last question here is, what's the area? So remember, the area is the length of each diagonal multiplied together times a half. It's 1/2 the diagonals multiplied together. Okay, so the area here is, the first slide was incorrect. The area is 1/2 diagonal 1 times diagonal 2. Well, we know what each diagonal is, right? So we said that diagonal 1 was 12 and 2 was 21. So all we got to do is 1/2 of 12 times 21. And I don't know what that is, y'all. So I'm going to go back onto my calculator and I'm going to figure that out. 0.5 times 12 times 21. And that gives me 126. Here. So x, y is, so it's asking questions. Is the measure of x, WZX 34 degrees? So I got to figure out, where is WZX in the first place? So WZX is that 34 degrees. Okay. So I just said that those were bisected, right? So we know that this guy, let's get that really tiny. This guy is 56. Okay. And so I would use that triangle sum theorem. So 90 plus 56 plus x is at 180 degrees. So is it 34 degrees? Does that make that work? So let's see. 180 minus 90 minus 56 gives me 34. So yes, that one should be 34 degrees. Is WXY 123 degrees? So let's see what we got here. WXY. And guys, this PowerPoint is on that page where you all can access it and download it as well. So if you want to be doing some of these with me, you can. WXY is right here. Okay, so is that 123 degrees? Well, we know that this guy was 34, right? And we know this guy is 34. So we know this is 67 because those are congruent. Those opposite angles are congruent. So what is 34 plus 67? So 34 plus 67 is 101. So 101, not 123. So no. All right. So now we've got to figure out, is XYZ 46 degrees? So where is XYZ? XYZ, is that 46 degrees? I've got a few ways to do this. One way that I think is easiest is if I go over here and I say, I know this is 67, then there's one big old triangle right here. So I can do 67 plus 67 plus, not times, come on, Zender, plus angle XYZ. Oh my goodness. Okay. X, Y, oh, come on. XYZ should equal 180. So again, I'm going back to my calculator and I'm saying 180 minus 67 minus 67. And that gives me 46 degrees. So yes, it's 46 degrees. The last question here asks about angle angle WPZ. WPZ. So where is WPZ? WPZ is right here. And yes, that one's 90 degrees, and that's because it is a perpendicular bisector, and that is always true in a kite.